are looking at similar figures, we actually spend one section focusing on just triangles, and the reason why we focus just on triangles is because they're pretty special. They have some special things that the other polygons don't have. So I'm just going to kind of have you recall from last semester the triangle congruencies. So if you remember the ways that you could say triangles were congruent by the shortcuts, it was SSS, SAS, ASA, and AAS. These shortcuts were used to prove that triangles were congruent so that you didn't have to do all 6 parts. So do you think some of these might be ways to prove triangles are similar, not congruent to each other, not twins, but similar? And the answer is yes, there are some of these that will work. So the first one I'm going to talk about is AA similarity, and we usually write it like this, AA wave. So AA similarity is used when you want to show 2 triangles are similar to each other, and you only need 2 angles, you don't need more than 2 angles. So keep in mind that some kids write AAA, but technically you don't need AAA, you just need AA. All right, so we're going to skip over this part. Let's go down and let me show you a couple of examples of how AA similarity works. So if you are given 2 triangles and you are trying to decide if they are similar, then what you would do is you would subtract these angles that you have from 180. And so I've already done that for you. I'm going to put these here. And when I do that, I'm going to notice that all of my angles match. Well, that's enough in a triangle to say that they're similar, not in any other polygon, but in a triangle. So these would be, yes, they're similar by AA similarity. Now, I'm going to make one similarity statement, and then we won't do them on the rest because they're pretty time-consuming. But just like we did in the last section, if they ask you for a similarity statement, you just match up the pieces. So if I go JLK, then I'm going to go triangle QMP, and that's called a similarity statement. All right, so let's see if we can get 2 angles to match in these triangles. So you might remember the vertical angles, and you might remember the alternate interior angles. So technically, I could use all 3, but you don't need 3 because as long as 2 match, the thirds will have to match. So will these be similar? Yes, they are similar by AA similarity. And again, you would write a similarity statement like we've been practicing. Okay, so go to 1A. I'm going to subtract the angles I know from 180. When I subtract, here's what's left. I get a 46 on that one, and I get a 43. I do not have 2 angles that match. That means that these might be similar in looks, but they're actually not similar mathematically. So no, they're not similar. And you would just say something like AA fails, or you don't have enough to say they're similar. And then on 1B, both triangles, the little triangle and the big triangle, they both have angle L, and then they have corresponding angles. So you can use any 2 of the 3 angles. You don't need all 3. As long as you have 2, you will be able to say that, yes, these triangles are similar by AA similarity. And again, then you would do a similarity statement with the little triangle compared to the big triangle. So that's what AA similarity looks like. It only works for triangles, nothing else. Okay, so flip the page over. Do you think there are any other shortcuts you could use with just triangles? And the answer is yes to that also. So we have an SSS similarity, and we have an SAS similarity. So keep in mind that these also will show that triangles are similar. So I'm just going to jump right into the examples so that you can see what these would look like. Okay, so down here, if I'm trying to test for, remember we have AA similarity, SAS similarity, or SSS similarity. I've got to make sure that I compare the sides proportionally to see if they work. So for this one, I have a choice. I could do SAS and use these included angles, but most of you probably would think, oh, let's check for side, side, side. So here's how you do it. You do exactly what we did in the other section. You take the littlest and then the medium and the biggest from this triangle. So 5 is the littlest, then 6, then 8. And you put those as fractions over the littlest in the bottom triangle, the medium, and the biggest. And again, you're making proportions to see if they divide to the same scale factor. So if you take your calculator and you divide all of these out, that will help you check to see if you're getting the same ratio. So I've already divided them for you, 0.4, 0.4, 0.4. That means our sides are proportional. which means I don't need to check the angles because I just set up here that side, side, side was a shortcut. So that means no angles have to be checked if you're working with triangles. So it says, are they similar? And I would say, yes, they are similar by SSS similarity, and this is the proof that the sides are proportional. Again, you don't have to check the angles because it's a shortcut. So it's not like what we did in the last section. If you have triangles, you may use a shortcut. Okay, for this one, you do not have parallels. So what I'm going to do is I'm going to mark this angle right here as a reflexive angle, and then I'm going to highlight the little baby triangle, and I'm going to highlight the great big triangle. And we are going to check to see if these triangles are similar. So when you guys use SAS, I want to point out that the A has to be an included angle like it was before. It has to be between your two sides that are proportional. So notice that I have the angle here, and I have an 8 and a 10 in the little bitty green triangle. And then I got to put who 8 and 10 go with. Well, 8 goes with 12. So how did I get 12? I added that 8 and that 4. And then who does 10 go with on this side? 10 goes with 15. And then the angle between is congruent, which is going to make SAS, if this works. So you're going to take 8 divided by 12. You're going to get 0.6 repeating. 10 divided by 15 is 0.6 repeating. So the sides are proportional and the included angle matches. So you would say yes by SAS similarity. And again, you would write a similarity statement, which I'm just skipping now because you already know how to do. All right, go to 2A down here. We're going to decide if these are similar. So when you look at the picture, do you see how you don't have any angles at all? So you can't use AA or SAS. So we're going to check SSS. Okay, how do you do that? Same thing. Small, medium, and large over small, medium, and large. And again, you're just checking to make sure the sides are proportional. Okay, so you would divide each of those. I've already divided them for you. You're going to get 1.3 repeating for all of them. So we would be able to say that these triangles are similar, yes, by SSS similarity, and you don't even have to check the angles. It's a shortcut, just like we did earlier in the year. This just is a shortcut to see if they're similar, not congruent. Okay, last one. Go ahead and mark your vertical angles. It's a bow tie. So we're going to check for SAS, and we already have the included angle. So this 10 is the smallest, and this 11 is the biggest. Over in the other triangle, 20 is the smallest, and 22 is the biggest. So we need to make sure that these are proportional in order to use SAS for each triangle. So this reduces to 0.5, and so does this. And because the angle in between is included, that means that yes, they're similar by SAS similarity. All right, so we're going to do the exact same thing on the next page. Just look at a few more examples of triangles. These are all triangles. They're not quadrilaterals or pentagons or hexagons. They're going to be triangles. So determine if you think the triangles are similar. So if you want to pause the video, if you're at home and you want to pause it and try these on your own, you can and check them. If you're in class, we'll just do them together. All right, I'm going to mark a pair of alternate interiors. I'm going to mark a pair of verticals, and then I'm going to stop and say I'm done. I don't have to do anything else. These triangles are similar by AA similarity. And then I would write a similarity statement. Okay, for number 2, I'm going to look at trying to use SSS. I could if I did Pythagorean theorem. I'm just going to do Pythagorean theorem for this triangle, and then I'm going to use SAS because that is one that's a little harder to use, so I want to show you how this might be SAS. So if I do Pythagorean theorem with this, I would end up getting 8. So I would set it up this way, and I would get 8 for this side. Now I'm going to check for SAS. So my included angles match, but does 3 over 6 go with 4 over 8? That's the question. So we have to make sure that 3 over 6 reduces to the same scale factor as 4 over 8. That totally does, right? It's 0.5 and 0.5. Okay, so we can say these triangles are similar by SAS similarity. Another option would be to get a 5 here with Pythagorean theorem and then use SSS. It works also if you'd like to use that. All right, Two more. Let's go to number 3. So when you look at something like number 3, there are no angles at all. So you cannot use AA and you cannot use SAS because you have no angles. So we're going to check for SSS. We've already done this. So go ahead and take your first triangle and put them small, medium, and large. And then take your second triangle and put them small, medium, and large. And that's because the smallest side always matches with the smallest, and the medium with the large and the large. Okay, so now what you're going to do is you're going to divide these straight down. So 6 divided by 4, I think I did it the other way around, so you could also do it the other way around and have 4 over 6. So that's going to be 1.5 and 1.5. Did I put that right? Oh, 1.5. Did that work? 8 divided by 5. Oh, 1.6. Okay, so what you've noticed there is, let me make sure that, yes, this does not work. Even though the rest of them, if I go 12 divided by 8, that's 1.5. This is really, really, really close. It might be distant relatives, but they are not similar because my sides were not all proportional. I had one fraction that wasn't, so I'd have to say not similar. We used SSS to check that, and it didn't work. All right, so we're going to check the very last one. So we're going to go small, medium, and large. Small 10, medium 15, large 20. Small 4, medium 6, large 8. And we're going to divide those to see if they work. Okay, so if you divide these, you should get 5 halves, so I get 2.5 for all of these. So that means that we can say these are similar. So it would be yes by SSS similarity. So honestly, I think the hardest one to do is side angle side. You just need to make sure that your angle is included between the sides and check 2 sides to make sure they're proportional. Just make sure you have that included angle to be able to work, okay? And then I want to remind you, you cannot ever, never use these shortcuts on anything but triangles. The shortcuts do not work for rectangles, they don't work for hexagons or pentagons, they only work for triangles.